Hello guys, welcome to my channel DSA Making Easy with Python 3. Over here I'll be discussing various data structures and algorithm process which will lead to like code optimization and hence it will increase the efficiency of your programming for the and space complexity. So in a particular code or program there are various approaches. We need to take the one which has the least complexity. So that is why the DSA is the fundamental part of a programming. So coming to this question, here we have been provided with an array which is a sorted array and it's rotated by certain units to the right hand side. So we need to find the sum of a particular, like a user has input, okay, this is the particular sum 16. So we need to find the pair of those two elements in the array which leads to the 16, and we need to bring those frequency. uh, the output will give the frequency. So if there is, let's take an example of this one. So the sum leads to 48. So maybe here it's 38, 38 and 10, 48, and that is frequency is 1. And if there by any other chances, if we have another pair which leads to 48, then the frequency becomes 2. So what happens will be, in the first approach we'll be taking a pivot. So there will be two pointers over here, left and right. L is the pointing to the smallest element, and R will be pointing to the largest element in that array. So first we need to find the smallest element L, and R is the pivot. Okay, so L is how we'll be finding the smallest element in an array, in a sorted and rotated array. So from the data structures point of view, if you see that in a sorted array, if you need to search certain thing, so we will be looking forward to use binary search technique. Binary search technique because it will lead to less time complexity, or log n. If we go by linear search method, then the time complexity will increase by n square. So we think this is the most efficient approach to find the smallest element. After finding the smallest element in a rotated array, we can see that 9 is the smallest element over here. And in an what happens in a sorted array is it's always like 9, 10, 11, 15, 26, 38. But when it is rotated by 4 units, what happens? This element, the least element, prior to the least element, the previous element will be the highest one. So 9 is here the L, and R will be the 38. So we find the L right now. We'll be using the binary search technique. In the code, what we'll be doing here is we'll be taking the size of the array as an input from the user, and here the size of the array, let it be n, and we have used a slicing technique in Python which will lead to like take only up to that n number of user inputs. So if we exceed, the user exceeds the number of input to 10, then the first 6 will be getting selected. So what happens here, array list of will be converting the whole thing into the list. And now we use the map function over here. Map function, what does it do? Map function basically it takes two arguments. First is the integer, and next is the what is the input will be. So here the input, we are explicitly we are converting the input to integer type, and we'll be splitting the input. Here the user will input 1 space 2 space 3 space, So it will be split, it will be getting split into the with the spaces here, and every character will be converted into the integer, and then it will be stored inside the array. You can follow the comments over here for the ease of access. So in a particular array, after taking the input, the user wants, we can use this as a user input. Okay, so nothing like that, it won't impact much, nothing will happen actually. So we are taking like the sum should be 16. So now what happens will be L is the smallest element, as I have told you before, that L is the pivot of the smallest element. So here will be this function min element bin search. So we'll be finding the minimum element by using binary search. This is the name of the function which I have given, and you will be passing the array arr comma n being the size of the array as the arguments. After passing that function will be called. Coming to the function, this parameters are there, a comma r. A is the array and r being the length of the array. So that how basically how the binary search works. We are taking left is equal to 0, right equal to r, the length of the array. We will be calculating mid. Now you will be thinking, why am I doing this? Right minus left divided by 2. So we are doing this to prevent overflow. Now if you want to, this is a sort of a quiz type thing. If you want to dig deeper, Google it, find it out what is overflow, and I'm pretty sure that you'll get the answer, but this is the most efficient way to prevent overflow. Now what we'll be doing from the mid, after calculating mid minus one element. So what is the mid minus one element? Here 1 2 3 4 5 6, we'll be getting 3 0 1 2 3. So is 8 is, we'll be seeing here what actually happens over here is 15 is greater than 6. 6 is our output, so the previous element has to be the greatest one next to it. So now we find, is 6 greater than 8? No. What will happen? Min equal to a of mid, but x no. So it will go to the else if statement. In else if statement, is mid plus 1 is lesser than a of mid, is mid plus 1. We calculating mid to be 3 0 1 2 3, is 38 lesser than 9? Nope. So mid is greater actually. Mid is greater over here, and then we will return that value to the minimum and return min. So this is the basic binary search technique you can learn from by Google or from Geeks for Geeks, and we'll be returning the value, the minimum value. I won't be explaining the code as a whole. This channel is just to show you the approach of a particular problem. We won't be discussing the algorithm in depth, we'll be discussing the approach. Like instead, if binary search, if you use linear search, as I have already told, it would be like the error will be, sorry, the not error, the time complexity will increase to O n square. But for better efficiency, we'll do this one. This approach is the great, and it will return the minimum value to this. So L is the minimum value. Now L of index. So the value arr dot index L will get the position of that element in this array arr, and R is the largest one, as I've told. Behind that index, the previous one has to be the largest one. The index minus 1, that is our index. So what happens here, we are getting the right element and x index. So number of pairs. Now another function we're gonna call L of index, R of index. The parameters are this arr and the sum what we want. So now we need to calculate the frequency. Again, going back to the top, LRAS, counter equal to 0. Here we are using this method of calculating. We'll be calculating this plus plus s. If it is plus plus, then we'll increase the counter. Counter is the frequency counter. And after, I'll not be explaining. Do comment below and let me know if there is any problem in this thing. If you can optimize it further, do let me know. It will be really helpful for the community, for the channel to grow and spread the knowledge. Okay, how to do programming. So this is the program which helps me count the frequency of those pairs, and after getting the pair, it will be returned to that k. So if k is greater than 0, it will give the sum and the frequency. Print number of, and else if it is not giving, then it won't be printing. It will say no pairs of that sum exists in the array. So the above code here is like much more smaller into single line problems using less if else statements, which will, but for ease of knowing things, you will much understand using this one, and then you can comprehend that into smaller thing. Everything is defined in the proper comments, so there won't be any issue for you to understand. So basically we'll now run the program and I will show you like what will be the output be like. So here taking 6 as the input, now taking array input, let's take 11, 15, 6, 8, 9, 10. So the sum is 1. So number of pairs for the sum 16 is 1. What is that? 10 and 6. That is only pair over here. Okay, let's check another example. We are taking the same array but with different sum. 6, 8, 9, 10. So number of pairs of the sum 16 is, okay, you need to change the sum. If you guys can do that as a user input, that would be great. 17, let's copy this thing, do this again, and the there is 6, control V. Okay, so there are two pairs which leads to 17. What are those two pairs? So those two pairs are like 6 and 11 and 6 and 11 and 8 and 9. These are the two pairs which only gives the sum 17 in this array. So I'll get back to you. Okay, so do let me know, like this is a small question over here. Do let me know the time and space complexity of this program. So I've already given you an hints if you are listening carefully in the previous part of this video, that the time complexity has drastically reduced using binary search. So what will be the overall time complexity and the space complexity? Do comment below and let me know about this, and it will be great if you guys can contribute as well. I will push this program and future programs in my Git repo, where you can get an reference to it, and do post, share your Git repo with much more optimized if possible than my program. I'm looking forward to it. Thanks a lot guys. Do like and share this video. Spread knowledge. Thank you. Bye bye.